enum and union, which is similar to the structure that we have discussed. And then we'll be talking about chapter 12, which is dealing with object-oriented C++. We'll get into some of the structures and definitions and the rules involved into object-oriented programming. But first thing first, let's discuss preprocessor. I'm sharing my slides. I hope you guys can see it. Yes?
Yes, Professor.
Okay, thank you. So if you remember back in the very first session that we started this semester, we talked about that preprocessor was one of the steps that actually one of the first steps that happens when you try to compile your code. When you compile your code, when you hit the compile button, one of the things that happens is the preprocessor step, and we're going to get into what happens in the preprocessor. But tonight we're going to be particularly talking about conditional compilation, which also happens in the preprocessor phase of the compilation. From the name of it, conditional compilation means that just like you had conditional statements, that meant when you try to execute your program, based on some condition, if it's met, you execute series of code. Otherwise, you may have an else clause that you execute another series of code, right? It's based on a condition. Now, when we talk about conditional compilation, it's exactly the same thing. The only difference is that condition happens at the compile time, not at the execution time. So that means that when you click on the compiler button and you try to compile your program, depending on the conditional compilation statements that you have in your code, certain lines of code may get compiled and get into the binary file, and other lines of code, again, depending on the condition, they get bypassed and they never get into the binary code. So conditional compilation allows certain lines of code to get compiled based on the definition of a symbol and or conditions at compile time. The important thing is it's at compile time. Now, one of the steps at the preprocessor is this conditional compilation. The conditional compilation happens during the preprocessor of the compilation phase. What other things happens is the compiler removes all the comments, because when we write comments are for programmers, right, for developers. The compiler doesn't care, right? So they just remove all the comments in there. If you have constant name, again, we'd use constant to stand out something, right? If you have constant name, they are replaced with their values throughout the code, right? If you have macros, again, those are expanded. The macro body replaces the macro name, right? And again, one of the bullet items that happens is the conditional compilation or resolve. Exactly what lines of code are going to be compiled and what lines of code are not going to be compiled. And we're going to be looking at several examples, and definitely there is going to be a question on the test, on the final exam related to this. So let's look at the conditional compilation directives that we have, and let's see what do they do, and then we're going to look at an example. First of all, the preprocessor directive for conditional compilation, we already talked about pound include. Anytime you want to add, content of a header file, you do a pound include on it. And all the source code that you have in that header file, it gets copy pasted right where you have your pound include, like stdio.h or stdlib.h, or even your own header file, like the one that you created for lab 6 and 7. All the content gets copy paste right there. Pound define, that's your constant. That's how you define a constant. That's what we mentioned, that the values are replaced with the names are replaced with the value. If def, if defined, if an identifier is defined, then all the code right after that gets included as part of compilation until you hit the end if, obviously, right? It's the same thing as if defined, if you want to spell out the whole thing, or just abbreviated version of if def is the same thing. If identifier is there, and we need to talk about it, what do we mean by that? All the lines of code until the end if gets embedded within the code and they get compiled. By this identifier, you could even set it within your program, or you could set it as you try to compile your code on the command line, or using Microsoft Visual by setting the parameters that, oh, by the way, when you compile this code, compile it with this flag on, for example, like a debug flag or something. We look at examples on this. Another one, pound if. Again, as you can see, there is a condition attached to it. If the condition is true, the lines of code that gets included, otherwise they get excluded. You have, I'm going to skip elif for now. You have the else clause as well, pound else, just like if else clause that you had. It acts the same exact way in here. If the condition is met, the if part gets included. If not, the else part gets included. And then you have the multi-branch, that's pound elif. Again, each of them comes with a condition, right? And the end of the if is basically you identify the pound and if. Just like you have a define in here, that you could define a symbol. In order, if you want to undefine that symbol, you just use undef, and from that point on, that symbol, it gets undefined. If you have logic based on that, whether something is defined or not, that's going to be determined based on that logic. Any questions on these before we look at an example? Look at the chat. Chat is quiet. Okay. All right. So here is an example that I have. The left-hand side is the source code that the programmer writes or the developer writes, right? It has comments, it has pound include, it has couple of constant, it has a macro, and then you get into the executable code. You have a conditional compilation, and then the rest of the code. So the filter or the middle line in here is what are the source, what are the code, what are the lines of code, in what shape and form that gets past the preprocessor right before it gets compiled, right? What lines of code? So this is a similar question that you're going to get on the exam, on the final exam. You'll be given a code, and you're asked what are the lines of code that gets passed through preprocessor right before they get compiled. So when that question, it does not mean that you go ahead and solve and give me the trace of the program. No, it's what you see on the right-hand side. What are the lines of code and in what shape or form? For example, if you have macros, they get expanded. If you have constant, their values are replaced, so on and so forth. So let's get into this. So as we discussed, the preprocessor. Again, I'm going back a couple of the slides. As you can see, comments, constants, macros, so on and so forth. So as the preprocessor looks at as you go through the compiler, the preprocessor removes the comment line. It removes the pound include, and it copy pastes whatever the content is on top of the program. So I didn't put it because it's a lot of information, right? It resolves all your macros and your constants. However, the way that they are resolved is, as you can see, for example, in here you have a macro call max. So the definition, as you can see, the definition has replaced the actual macro call. Okay? Here is the body of your macro. So the definition of the macro is replacing the call to the macro. And then in here, as you can see, there is a symbol in here, which we're going to get into momentarily. As you can see in here, there is a constant, right? The value of the constant is replacing the constant name. So that's what happens during the preprocessor, right? And then you have the int made void. Your variable names or declaration remains intact. And then your printf statement remains intact, your scanf remains intact. We already talked about this. Macro gets expanded. Now in here, when it comes to here, it's checking to see if debug symbol is defined. So you look up your program, you see that debug is defined at this level. So since it's true, since this definition is defined, since this symbol is defined, then this line, this printf gets included as part of the program. If it wasn't defined, then you wouldn't see this statement in your code. So for example, if I want to debug my code and I want to see what was the value that was entered and what was the maximum value out of the A and B, I can do that, right? And if I compile my code without the debug symbol, I don't get that, and I get a clean output, right? And then we'd already talked about in the area, the value of 3.14 gets is replacing the pi, and then the printf and the return remains as is. So as you can see, these are the changes that occurs to your program, to your source code, as you run through the preprocessor step. Okay, so it has nothing to do for you to run the program, to generate the output, none of that, right? We just want to know what are the statements that gets to the compiler and they get compiled. And that's what gets to the compiler and they are compiled. Any question or comments at this point before we look at few examples? I'm not hearing anything. And the chat is quiet too. Okay. So, all right. Let's look at the second example related to this. Let me find it first. The program, the example is on page 658. Example 11-17, page 658, example 11-17, C-comp.c. Let me bring it up. All right, and let me share. Are you guys able to see the code?
Yes, Professor.
Okay, thank you. So in here it says, accepts input of information about the customer from standard input, and stores the information in a file name statement. It tries to implement conditional compilation. So the gist of the program is about, for example, if you have a customer, as you can see in here, you have for example, you have an ACME customer versus non-ACME customer, right? If you have an ACME customer, the account number is 9 characters, for example, but otherwise the account number is 17 characters. So you are fully capable of doing this rather than replicating the code over and over again. If there are minor modifications to your program, but everything else is shared between one customer and another, there is no point of duplicating your code, right? Because if you duplicate any change that any modification bug fixes you do to one, you have to do to the other. Any test you do to one, you have to do to the other, because everything becomes double, right? But if there are minor modifications, then conditional compilation would be one of the better routes to take in order to keep the code the same as one code, but handle the minor modifications internal to your code by conditional compilation. So as you can see in here, structure statement for customer ACME is different than the rest of them. So and then when you try to compile this code, you can compile this code with the ACME customer. You specify on the command line, like compile this code with the symbol ACME on, or when in Visual Studio, you could say compile it with this parameter on or off, right? The balance is the same. Again, another structure within the statement structure. If ACME customer T code is a 5-character array, otherwise T code is an int. So as you can see in here, right? So either when you have a dealing with ACME, this line gets included and account 17, and T code gets excluded, and other way around, right? Quantity and price, they're all float, and you're dealing with transaction array of 50 of these structured transactions, right? So you have a get customer function. So the main function basically tries to open up the statement file for writing purposes. It checks the fopen status against null and prints out an error message and bails out, right? If it was successful, it says enter your customer transaction, signal EOF when you're done, and you are in the while loop in here. As long as you have a customer, you do a fwrite on the structure and you write it to the file. So you get a customer, which is one of those structures, and whatever you got, you are printing it one at a time to your size of the customer, one of them to your output file, and then you end at that point. So let's look at the get customer function. Passes in a pointer to a structure. It says enter customer name, and then reads it into the name member of the structure. It says enter customer account number. Now again, if you're dealing with ACME customer, you'll notice that your account number, your account was 9 characters. You're preserving 1 for null, so you read 8 characters. Otherwise, you're reading 16 if it's a non-ACME customer, so on and so forth. So the rest of the code. So it's trying to show you that you could do minor modification in here for ACME versus non-ACME customer, and then when you try to handle like read or print or whatever, you have to handle it within the conditional compilation. So again, depending on which customer you're dealing with, either one line, this line, or the other line is included. Everything else is going to be excluded. Question on this? Okay. Let's move forward. One more example. Example on page 661. Example 11-18. Example 11-18, page 661, recurse 2.c. Let me bring it up. Okay. Yeah, let me try to run this, set it up to run this program. 1 second. I'm trying to just set up the environment to run this program so you can see it in action, what happens to it. Okay. We need to do some modifications to it. Okay. And run. Yep. And we are in business. Okay. All right. Now let me share. Okay. Please let me know if you guys can see the code.
Yes, Professor.
Yeah, we see it.
Okay. Thank you. So recurse 2.c, it says accept input of a positive integer, calculate factorial, and displays the result. So this is very similar to, in fact, identical to the example that we had seen before, going back to the factorial and the convert function. The only difference is now they have created some macros in it in order to debug the code. And this goes back to the conversation we had last time when we were talking about macros. You could write debug statements in your code that you could turn it on and off depending on the situation to give you some information when you need it. So what I've done, I just turned on the debug in here. I just did a pound define debug. I turned it on in here. And let's look at each one of them. If debug is defined, which I already have it, I want to include these things, these macros. These are macros that I have in the code. Enter function and exit function, which basically anytime you enter or exit a function, it tries to say, hey, you are entering this function, you are exiting this function with a function name. And some indentation. This has to do with the indentation, as you can see momentarily, right? So these are what those macros are all about. Otherwise, if the debug is not set, you notice that the body of the macros are, they are empty, right? That means they don't do anything. It's like a no-op. And if I comment this out, I just want to show you. If I comment this out, you notice that these things are not there anymore. They are kind of, grayed out, showing you, which is in the nice compiler, showing you that this is the active one. And if I turn it back on, you get the other way. That means this is active. These are disabled. So it's just graphically showing you which one is enabled or disabled. So it's the same factorial function, convert function, error. Each function that you have, you have a enter and exit macro showing you that, hey, you're about to enter this function and you're exiting this function, right? Same thing with the factorial function, enter factorial and exit factorial in two situations. Convert function, same thing, enter, convert, and exit. There is an extra statement in here. If you are in the debug mode, you want to see what was the sum. So this way, it would be a good opportunity for you to follow and see what your code does. And if there are any errors in there, you'll be able to see it immediately when you try to print your code, some of the variables in your code. And same goes with the error, the enter macro and the exit macro. So what I want to do is run this now. Run this. Oops. Well, let me share this as well. Are you able to see the run in here, the run window, the black window that I have up?
Yeah.
Yes, sir.
Okay. So it's, as you can see, any you enter main, it says enter main, program to calculate factorial, enter positive value. Now you are in the convert function. So if I enter a value of 5, you'll see all these debug messages showing up in here. I hope you are able to see the entire thing, and you see how they are nested. They are nested because it helps you to see how many times the convert function or factorial function is called, how many times your exit, because for every entry, they have to be an exit. Otherwise, you get yourself into a undetermined situation, especially if you're dealing with a recursive function. So you enter the convert function, you exit the convert function, and then here you enter the factorial, another one, another. Remember, this is a recursive function, right? When it comes to 0, you start exiting. You start exiting the factorials, right? So how many? 1, 2, 3, 4, 5, 6 entry we had. 1, 2, 3, 4, 5, 6 times that we are exiting the factorial function. And then at the end, this is the result. 5 factorial is 20. Again, an example of what you can do in here. And then toward the end of it, you exit the main function, and that's the end of it. So again, it's just trying to show you that what you can do with macros, what you can do with conditional compilation. Now, if I had a situation that it was reported that there is a bug in my code, I can simply leave the code as is, just turn on the debug flag or symbol and run it and start debugging, look at the messages and things like that. Whenever I'm done, I can compile it without the debug message, and that's what gets shipped, for example, to the end user or to the customer. Any question or comment on this? Okay, no question. You check the chat. Chat is quiet. Okay, and that's the lecture for the preprocessor. If you have questions, make sure you unmute yourself and you speak up. All right. The next topic, which we're going to jump into, is two-dimensional arrays. So far, we have discussed one-dimensional array, which is really a list of items, whether the list is integers or characters, or a list of pointers, pointers to structures, or list of structures themselves. These are all one-dimensional array and lists. Two-dimensional arrays are things that are in tabular format, something that has rows and columns. Best thing that comes to my mind is like your Excel form that has a bunch of rows and columns. It has a lot of implications in computer programming, a lot of gaming, especially anything that has to do with board. When you have a value like chess or I don't know, like tic-tac-toe or checkers or something that has values that they are two-dimensional, definitely, that would be a good candidate for usage of a two-dimensional array. But two-dimensional, they are just like, any array that you have. Instead of dealing with one index, since it's composed of rows and columns, you have to deal with two dimensions, the number, which row and which column you're dealing with. So they act like a table with rows and columns. They can be initialized just like one-dimensional array. They can be initialized at the same time of the declaration. Just like, again, by definition, the name of a two-dimensional array is the pointer to the first cell of the array. That means the first row, first column. By the way, anything that we are saying in here regarding two-dimensional array, it also applies to multi-dimensional array, like three-dimensional or four-dimensional, and so on and so forth. The way that you would declare a two-dimensional array, you could have a constant for rows or columns, and then you say, for example, int table is the name of the array based on 2 rows and 3 columns in our example, right? So at the bottom you have 2 rows, 3 columns. These array indices start from 0 and 1 for the rows and 0, 1, 2 for the columns. And not only that, you could declare your array, and at the same time, you could initialize your array to values of 1, 2, 3, 4, 5, 6. And that's what you have. And then table is the name of your array, which also acts as a pointer to the first element of your array, which is this one. Okay. This is graphically how we show a two-dimensional array, but technically, when you look at the memory in the computer, a two-dimensional array is saved on the memory, nothing other than a consecutive memory location, and this would be the first dimension, and this would be the second dimension. So 1, 2, 3, or this memory followed by 4, 5, 6, immediately following that. And I have examples later on that which we're going to get into. How do we populate a two-dimensional array? How do we read to it? Since you're dealing with 2 dimensions, number of rows and columns. By the way, the first bracket, the first index is always number of rows, and the second one is always number of columns. Okay. Just because we have 2 dimensions, we have to have a nested loop, because not only we have to hit all the columns for the first row, and we have to hit all the rows, right? So you have nested loop. One loop deals with rows, another loop deals with columns, and a nested loop that's asking the user to enter a number, and then you just can read the value that the user enters and directly enter it and populated your two-dimensional array. How do we print a two-dimensional array? Exactly the same. You define your array, and again by nested nested loop, you basically print each individual element of your array. Okay. I'm going to pause. Any questions or comments at this point?
Professor?
Yes.
Could you go back to the previous slide real quick, please?
This one?
Yeah. Okay, thank you.
Sure. Other questions? Okay. So we discussed how to declare the array, how to populate the array, initialize the array. You can use it in an assignment statement, how to can print it, the array. You can also pass to a function, just like you pass one-dimensional array. Anything that you do with a one-dimensional single variable, you can also do with a two-dimensional array. The storage class, the scope, initialization of multi-dimensional array is exactly the same. When you pass a multi-dimensional array to a function, every dimension except the first one must be known to the function. And we're going to get into here and see why. When you're dealing with a two-dimensional array, the last bullet item says in C, two-dimensional array are stored in a row-wise order or operation. So as I said, to a C program, table is not what gets stored in memory, right? To a C program, everything is a one consecutive memory. So this is the first row, this is the second row, and third row, so on and so forth, right? As you can see in here, right? So table is a pointer to the first memory of the first cell or first row and first column. If I advance that table by one, that means go to the second row. So depending on how many rows, how many elements I have, how many columns I have, it jumps to the forward by x many bytes. So table plus one will be pointing to the first element of the second row, which would be here. So as you can see, you have the first row, second row, third row, fourth row, so on and so forth, right? That's how it's stored in C language, and most other programming languages nowadays, they store the memory, the two-dimensional arrays element in a row-wise format. There are other programming languages. For example, Fortran was one of the languages that it would save the first column first, and then followed by the second column, followed by the third column, so on and so forth, right? So depending on the language, they may be different. And that's why, since in C, we are dealing with a row-wise operation, right, like what we have in here, it makes sense to have, when we have a nested loop, it does make sense to make the outer loop the number of rows, and the inner loop is the one that goes faster, make it associated with a column, because as you progress, first row, first column, first row, second column, first row, third column, second row, first column, second row, second column, second row, third column, right? So the pointer, it goes one by one without a lot of disturbance. However, if you had this loop on the top, if the columns were the outer loop and the rows were the inner loop, then the way that it would work is this pointer would go first row, first column, second row, first column, which would be here, jumps back there, first row, second column, second row, second column, so it goes back and forth. First row, third column, and second row, third column, right? So it goes back and forth, back and forth, back and forth. And of course, that pointer arithmetic is not going to be, not efficient. Of course, it's going to do the job. The output is going to be identical, no problem at all whatsoever. But you're going to compromise on the speed, because you're making that pointer to jump ahead, a lot of back and forth, rather than going into the consecutive memory location from one memory to the next, to the next, to the next, right? Those pointer arithmetics back and forth, it does add up, right? So anyway, that's something to think about, but the program works great, exactly the same. not an issue. It's just the pay would come from the efficiency perspective. Any questions on this? Okay, so let's take an example in here. Yeah. There's an example on page 515 of your book, example 9-3. Example 9-3, page 515, multi.c. You find it?
Hello, Prof.
Hello.
Yeah, please, what page is the example?
Example is on page 515, 515.
Okay.
Example 9-3, multi.c. I'm sharing the code. Are you guys, I think I'm sharing. Are you guys able to see it?
Thank you.
Yeah, we can see that.
Okay, great. All right, so this is like a multiplication table going with 4 rows and 5 columns, right? You have a print table function. You have the main function in here that multi-array is has 4 rows, 5 columns, and they have a a loop in here for each row and for each column. They multiply row times column and they populate it into your 2-dimensional array, and then they call the print array, right? By passing number of rows, number of columns, and the actual name of the array. And as you can see, when we discuss every dimension other than the first has to be known, because the compiler needs to know when you advance the pointer by 1 row, where do you land on? So it needs to know how many columns does it have, right? So that's why you have to specify the number of columns in here. So the print table function, you set up your i's and j's, and then it says as long as the row is less than less than rows, you basically print out the values of array sub I sub j, and then this is some kind of formatting, right? This is a conditional statement. If j is columns -1, you print out a new line, otherwise you print out a tab, right? That's how you read that. Conditional if is or conditional operator question and colon means if this is true, you execute this, or you return the middle one, otherwise you return the last portion, which is a tab. So this way you print out the lines by itself, and then each time you bump, and then at the end of that loop, basically you print out whatever you need depending on the values of the I and j that you have, and you do your update statement. So if you can simply change this to a values of rows and columns of 11 by 11, you get yourself a multiplication table from 0 to 10, and then it's as simple as that. So that's what those constants give you, right? You can simply change those without any other change to your program, and you get yourself an 11 by 11 table rather than a 4 by 5 table. And as you can see, these constants, rows and columns, are used throughout the code, so you don't have to hard code anything in there. Otherwise, you had to come here and change any one of these to a desired value that you want. questions on these? Okay. One more example. So that's for two-dimensional array. When we talk about multi-dimensional array, we are talking like three-dimensional array, same exact concept. With a three-dimensional array, you have something like an x, y, z coordinate, like a point in the space, which has three coordinates, x, y, z, for example, or you have a length, width, and height, something three-dimension, or things in that nature. And with four-dimensional array, you could imagine that you have that point in the sky like a satellite in the space, but the fourth dimension becomes like t, which is the time at time t, the satellite is at such and such location in space, but t+1 would be at another space. Computers definitely could go beyond fourth dimensional array, but our human mind, not sure if we can think about fifth dimension or sixth dimensional spaces. It's at this point is unknown to us. Maybe some of you may end up graduating computer science and maybe doing some of these things in the future. But the same exact thing when you have, for example, three-dimensional arrays, you're going to have three brackets, three indexes when you define your array. And in order to populate the array, in order to access any element of the array, to print your array, you need to have three indices like I, J, K, or A, B, C, or X, Y, Z, whatever those dimensions are. We can look at a three-dimensional array in the book. The example is on page 519 of your book. Example 9-4, page 519, 3dim.c. So in here, they have three dimensions, an array of 2 by 3 by 4. Here the name of the array, 3D, with those dimensions. And they initialize each one of them, initialize the array, right? Here is the first dimension, right? The second one, and each one of them is 3 rows, and each row is, here are the values, right? And then in order to print the entire array, as you can see, there are 3 nested loops, one for dim1, another. So, and every time you print something, of course, you have to have 3 indices in there. And on page 522 and page 523, it discusses, how a two-dimensional array, for example, are located at. How do you access them? Using pointers, as I had it in here. The name of the array is the pointer to the first element. If I bump the pointer by 1, I'm looking at the next row. If I dereference it, I'm basically looking at the first cell of the second row, or first cell of the first row, depending on which one, and then so on and so forth. In order to look at the content, I have to do double indirection, right? So for example, this content in here is dereference table, because dereference table is the pointer to the first row, and then dereference of that's the content of the first cell in there. So again, those are something if you're interested to look into the depth of the two-dimensional array notation, pointer notation, welcome to look at it. Again, it's identical to what we have discussed so far. Any questions or comments on these? As I've been talking, number of students are increasing, which is good. Anything on the chat? No. Any questions at this point before we take our first break? Okay, I'm not hearing anything. So yeah, it's 6:32. Let's take a 13 minutes break. Come back at 6:45, and we continue. Let's see. You guys able to see the slide?
Yes,
Yeah.
Okay. All right. So the remaining item of discussion is the bitwise operation, which I'm not going to discuss that. There won't be questions on it on the exam. It's a simple read. If you read those sections, the same way that you, for example, AND two operators, two operands, like in order for it to be true, both of them has to be 1. It's the same thing goes with the bitwise operation. 2 ones makes a 1, 1 and 0 makes a 0, 2 zeros makes a 0. Same thing goes with the OR. If you have 1 0 or 0 1, they're 1. 1 and 1 of course is 1, and 0 and 0 is the one that is false. So it's the same concept, same idea. It's an easy read that I expect you to, if interested, go read in the book. But it's the same thing. There are a couple of sections in, I believe it's chapter 7, right after the structures that we're going to discuss. They are namely enum and union, which they're offset of the structure, and we're going to see examples for each. Enum is basically, it's an enumeration list. The format of it is very similar to what you have with the structure. You have an enum as a keyword, and then you have the name of your enumeration. Like in this case, I have color, which has the values of red, white, and blue, for example, right? So if the color is the name of the enumeration list, is the definition of the structure. And then if I want to declare variables based on that enum, all I say is like enum color, and then C1 and C2 are my variable name. Now, why this is useful and handy, it adds to the readability of the program. How? So for example, if I'm dealing with red, white, and blue, instead of saying, for example, if I didn't have this enum, I had to set, red equals 0 or white equals 1, blue equals 2, right? And then I had to write code, or I could have, create constants in my code, in order to handle it. But instead of that, I could create an enum which the values of red, white, and blue is nothing other than 0, 1, and 2. The value of red is 0, the value of white is 1, the value of blue is 2. That is the same with any enumeration list that you have. And then when I write the code, I could simply say, like, if C1 is white, then do whatever, right? So looking at the readability of the program, rather than saying, like, if C1 is 1, now I may forget what is 1. Now I have to go back up and search my code and see what constitutes 1. Oh, it was white. Okay, now I understand that. But rather than that, I can simply say, if C1 is white, do this. Same thing could be said about like suits of the card, right? You have, suits of the card could be as an enumeration list. You have hearts, you have diamond, you have a spade, you have clubs, and then depending, and you could say, like, if diamonds, then do whatever that you want to do, right? Again, it's basically adding readability to the code. And of course, you could have a type def as well added to these structures, which enum is actually a structure, is the offset of a structure, is a special structure, right? That the values in there are start from 0 and go on. We're going to look at an example in here momentarily. Any questions on the enum? Okay. The next one is union. Again, this one is also an offset of a structure. Now, for the union is a keyword, and then you have the name of it. In this case, you could have a union is you could have members, but at any given point, one or the other member could be used. So, so again, this is the definition of the union. And in order to create a variable based on this newly created data type union, all I have to say is union rate and then pay rate. So pay rate is a variable name that either you have a per hour member or per week member, depending on the situation, not both, right? If someone works hourly, for example, it would pay rate dot per hour makes sense. If someone is working based on salary or they get payments like every week or so, pay rate dot per week makes the most sense. And then again, it's one or the other, and we're going to see that in action in an example shortly. So before we talk about union, let's look at an example on the enum. The example is on page 416 of your book. 416, example 7-9. Enum index.c, page 416, example 7-9. Enum index.c. Let me bring it up in the compiler. Enum index.c. Oh, I need to also share. Are you guys able to see it?
Yes, Professor.
Okay, thank you. So in here, this program says accept input of a number sold of each color of an item, stores the number in an array, and displays the content of an array. So you have a couple of constants in here, record size and color length. Look at the enumeration list. You have different color of a shirt, for example, jade, navy, white, coral, and maize. So jade is 0, navy is 1, white is 2, coral is 3, maize is 4, right? And then you have a couple of functions. The main function, you have a cells record array of record size. You call the function get cells and print cells, right? Let's look at get cells. The get cells in here, you have the enumeration list. So you pass in the array, you have your enumeration list. It says enter number of each color sold, and then look at the for loop. The D color going from jade until less than or equal to maize, right? So this is a clear indication that enumeration list or these colors, they act like integers, right? From beginning to the end of it, from when the when its color is jade all the way up to the end of it, which is maize, and each time you're adding 1 to the D color, which means you're increasing it. You call the next string. The next string function is here. They use a switch statement for the color. Again, if the color is jade, you string copy jade into a string. If it's navy, you print string navy. If it's white, you print white, so on and so forth. Again, you're seeing that how they use these enumeration lists as integers, right? So after they make a string, you print out the color string, and then they read that value that the user entered into the array sub B color. Again, that's your array index. Jade is 0, I don't know what was the red was 1, white was 2, so on and so forth. And then when it comes to print, they go through a loop, one element at a time, and they just print. They make a string out of it. Again, they make a passing an index. They make a string out of it, and they print out the string color and how many it was sold. The count that it was sold. Again, here is your enumeration list that they act like integer. So you see how it would add to the readability rather than using 0, 1, 2 that you don't remember what was 5, right? What was 3, what was 2. Now you can see that 2 was white, for example, right? You don't have to memorize those counts. Any questions on these? Let me check the chat. Nothing in there. Okay. Next example is about union. That example is on page 423 of your book, example 7-10, unions.c. Page 423, example 7-10, unions.c. Let me bring it up. So here is an example of a union that you have. It says accepts input and displays information of an employee. You have a bunch of consonants in here. You have an enum of a type, hourly or salaried. So hourly is 0, salaried is 1. You have a union. You have per hour or per week, right? The rate is either hourly or weekly. And then you have a structured employee. The members of a structured employees, you have name, you have social security number, you have pay type, which is the enumeration list. Which one is it, hourly or salaried? And then you have your union pay rate, okay? So your main function, you have a struct employee imp, right, which is defined there. And then you read an employee and you populate your imp structure and you print an employee by printing content of your structure. So the read imp, it says enter information of an employee into a SQS under name, populate the name member, and you put a null character there. You read a social security number, you populate the SSN member, and then you put a null character there. Now it says if you are dealing hourly or salary, H or S, which one, and then it reads, right? If it's dealing with the H, which is hourly or capital H, you set the pay rate to hourly. As you can see, the pay rate is hourly or salary, right? So the pay rate would become per hour. So sorry about that. So it's either hourly, if the user enters H or lowercase or capital, hourly is the value that gets stored, which again, if you look at the hourly value in here, equates to the value of 0. Otherwise, the value of 1, which is salaried, gets stored into the pay type, which is a union. Okay. Now, otherwise, if it's not either one of them, it says illegal. Okay. Now, in here, this is an interesting one. If the pay type was hourly, it's asking for pay rate. What is your hourly pay rate? Otherwise, if it was not hourly, it says what is your weekly salary. And notice where they store each one. They store it in the pay rate dot per hour or pay rate dot per week. And this is your union. Again, I'm scrolling back up. I know I'm going back and forth a lot, but here is your pay rate. The pay rate is either hourly or salary. Look at here. It's either per hour for hourly or per week for weekly, right? So in here, as you can see, if you're dealing with hourly, you're dealing with the pay rate, which is your union per hour, or pay rate, which is the structure per week, which is your union, right? And then that gets stored there. So that's how you would populate a structure. In order to print it, you pass in the structure, you just simply print each member name, social security. Again, if pay rate is hourly, you print out imp.payrate.per hour. This is your structure member, and this is your union per hour or per week. So one or the other appears, not both. So you could do something like that, or you could create different variables for that purpose. But doing a union, it kind of gives it some shape or form or some standardization around the members of the structure. Any questions on this one?
So this is done in case you need different, I guess, data type for a certain thing.
Yeah, you could have different data types. As you could see in here, the rate, depending on whether it's hourly or weekly. Weekly is int, hourly is double. Absolutely fine.
Okay.
You could have mix and match of the data types. Yep. See if there's nothing on the chat as well. Okay. Any other question? Okay. So let's discuss the object-oriented. Unfortunately, we don't have time to do a lab assignment on this. And I definitely encourage all of you, if you're going and continuing in the computer science, and to take any of the object-oriented language to read this chapter, or at least do a couple of the examples that they have in here, and try to do those assignments. But I briefly discuss the important points of the object-oriented programming, and then discuss the concept. So hopefully when you read the chapter, it's not going to be so overwhelmed. It's an easy reading anyway. First of all, the pure object-oriented programming is not Java, is not C++ or C# or anything like that, or Objective-C. It was a language called Smalltalk. Smalltalk, it never took off, but it's considered to be the pure object-oriented language. Procedural languages like C or Fortran, COBOL, or Pascal, or things like that. Even C++, if you write it in procedural language, there are two things that you're dealing with. You're dealing with variables and you're dealing with functions. The variables and the functions are your bread and butter when it comes to programming, okay? When you're dealing with object-oriented programming, you're dealing with attributes and you're dealing with methods. What we call variables in a procedural language, they are called attributes of an object. What we call functions in a procedural language, they are called methods in an object-oriented language. First of all, when you're dealing with an object-oriented language, everything is an object, right? Now that object, there are some, every object has some characteristics, right? What's the color, right? What are some of those characteristics of that object? Those are called attributes. What you can do with that object or what that object does, those are the methods or the functionalities or functions that we called it in a procedural language, right? So the way that you create an object, you go to C++, for example, the way that you create an object, you'll notice that you create a class, you create an object, you create a class. That class is nothing other than a structure. It's actually a structure. You create a structure, that structure has some attributes, it has some methods, which they act on the attributes, or it could change the way that that object behaves, right? You could have some constructors, destructors, so on and so forth, right? The main important thing about any object-oriented language is they need to follow three principles. They are encapsulation, or data abstraction, polymorphism, and inheritance. If a language doesn't have one of these three characteristics, that language is not called an object-oriented language, okay? So I want to go briefly into each one of these and define what these are, and maybe we have seen examples of it already. The first one is encapsulation or data abstraction. This concept deals with hiding details, right? So the implementation that we have, not anyone, not everyone should be able to say how I have implemented something. They may be able to use it, right? But not without knowing how the implementation was done. Think about the stack example that we went over, right? Without knowing how the stack was implemented, that I had like an array which defined the elements of the stack, and then I have the top of the array, which was the index of the array. Without knowing that, I still could use the stack, right? If you tell me, hey, these are the functionalities or methods that I have associated with the stack, I could call it. I could use those methods or those functions in order for me to accomplish something. And that's what data abstraction or encapsulation is. You don't have to specify all the details of your class as long as you give the API of your class and, hey, these are the functionalities of this class. This is what you need to do in order to use this object. These are the things that you could do. That's good enough, right? So this way, you write the code, then the actual implementation of the code is hidden. You control that, but others